Welcome back to TechEd North America 2012 in Orlando, Florida. We are live and we are going to be sending you back up to the Taste of TechEd here shortly. But first, I'm going to go all fanboy. I've got Active Directory Guru. Isn't that officially in your title?
It's not in my title, but I'll take it.
All right, well, Program Manager Dean Wells is here. How are you, Dean?
Thank you very much.
So, of course, you can always interact with us. You want to tweet your questions to hashtag CH9Live. You've got those Active Directory questions. Dean's going to be here, answer some of them. We're going to chit-chat a little bit because there's been a few changes. A couple things, one or two here, not only with Windows Server 2012, but also when we made the announcements last Friday. Mark talked a little bit about it in the keynote yesterday.
Yeah.
About actually running Active Directory inside of a virtual machine in Windows Azure.
Yeah.
Which is a little different than what we've also heard Windows Azure Active Directory.
Yeah, there is a distinction between Azure Active Directory and Windows AD or AD domain services or federation services for that matter, running inside a Windows Azure virtual machine. Azure Active Directory is an authentication and authorization product that runs up in the cloud. It's part and parcel of Azure. It's typically leveraged by developers for their own authentication and authorization purposes. All claims-based, comprises a number of our products such as Access Control Services, ACS. ADLDS is in the mix somewhere. That sits way buried beneath the covers so that you don't get to see it, but it's in there nonetheless. And it's also the authentication piece that sits underneath O365 for Exchange Online, etc. users.
So clear distinction. We are first going to cover basically running a domain controller inside of a virtual machine running in Windows Azure to support applications.
Yes.
So the first question is, and we'll get to the virtual machine aspects of it later, there are some very unique things in the way that Windows Azure is set up, right? And running virtual machines inside of Windows Azure. And just like when we set things up on premises, we have to make sure we do proper things with our log files and so on and so forth. What are some of those key things that we as administrators need to do to prepare a virtual machine running in Windows Azure so that we can start deploying some of these on-premises applications up into the cloud and into Windows Azure?
Well, as much as it may be the canned response, great question, that really is the great question. We conducted some fairly extensive testing recently around this for both Active Directory domain services and Active Directory federation services. The result of that testing came to light about 2 months or so ago, and we essentially signed off on both. So both products run exactly as expected within Windows Azure Virtual Machine. We did encounter a few bugs along the way, one of which was actually in Active Directory, and it highlighted something we'd never seen in the field before, which we fixed. That specific bug was an absence of retry logic in DC Promo when promoting domain controllers across very slow links into very large Active Directory databases. There was no retry logic there in DC Promo itself. The replication engine, of course, has much retry logic, but DC Promo did not. So we kept failing and we couldn't figure out why. So we figured that out and then actually fixed that in Windows Server 2012. In addition, that slowness was by virtue of one of the features that was existing at that time as Brooklyn, Project Brooklyn, that eventually manifested as VNet or Windows Azure Virtual Network. And the slowness is not something that's going to be carried forward into the shipping version of the product. It's simply that there were tens of product groups all leveraging precisely the same site-to-site VPN back to the corporate network. So we were sharing that bandwidth with them. So the lessons that we learned having tested this were as follows. I think there are 3 key learnings. The first one is this, and it's the most important in my opinion. Contrary to every piece of best practices guidance that we've put out there for the past 10 or 11 years, you cannot use static addresses on domain controllers running in Windows Azure Virtual Machine. It does not support static addresses, period. As a result, administrators have to change the habit of a lifetime and make sure that they always configure their domain controllers to use leased addresses. Now let's just be clear, that leased address doesn't change in the same way as it does with a DHCP server. The semantics differ. Once you've leased it, it's yours for the lifetime of that virtual machine, akin to the lifetime of that entire deployment, essentially. So it becomes what I like to term as pseudo-static. But
it's a great term.
It's a good term, yeah. But if you were to go ahead and configure it with a static address, or if you think you're going to get smart and wait for it to lease an address and then go and add that one statically, you're going to break it. It may appear to work for a limited period of time, but ultimately communication with that VM, both within the cloud and between your on-premises network and the cloud, will break.
I can actually follow up and say yes. You are 100% correct.
You can attest to that, good man.
Well, yeah, because the first thing I do as an administrator, right? I've deployed AD a ton of times, a ton of domain controllers, all the way back to, the earliest versions. The first thing I always do is go in, set the static IP address, and then even if I'm like, oh, look, it's just DHCP, we can just get the address and then we'll set it.
Yep.
The minute I did that, yeah, bye.
I would do exactly the same thing. So this is the first thing that I mentioned. I think I mentioned it about 10 times in my session yesterday, just to try and drive the point home. The second thing is the placement of the Active Directory database. For years now, we've been saying place the Active Directory database, the DIT, the logs, and sysvol on separate spindles. That was typically for IOPS throughput. We wanted it to be as fast as it could possibly be. With today's hardware, with the SCSI bandwidth that we've got, the spindle rates of these drives, and certainly with SSDs being thrown into the mix, that recommendation is almost rendered moot because they're so fast by themselves. The systems have so much RAM, their dependency on disk is lessened. But there is one specific component that still holds true in Windows Azure. There are two, in the infrastructure as a service offering, there are two distinct disk types. One called an OS disk and the other called a data disk. OS disks, not surprisingly, are where you deploy your operating system. That's the one that you get without really asking for anything. When you define a virtual machine that's going to be a DC, you have to add a second data disk. Now, if you don't do this, and this is the bad part right now, and obviously we're going to look at adding templates to make this smoother going forward so that we can carve appropriate deployments of virtual machines according to the role that's running on it, but today we don't have that. So for the moment, if you were to deploy a virtual machine without creating a data disk and you ran DC Promo, it's going to work. But you leave yourself in a risky position because the OS disk supports write behind caching. So essentially we end up with this buffer in between a write operation, that write being confirmed to JET or ESI, depending on how you prefer to phrase it, the extensible storage engine in which Active Directory resides, and the actual controller committing it to the disk and the disk committing it to the media. We can't allow that difference to occur. We must only be told that the write has been committed once it's fully durable. If we, for example, lost that virtual machine and the cache goes with it, but we'd replicated that change out, we've now introduced that wonderful term that we've come to know and love called a USN bubble.
Yes.
And we don't really want that because that type of error in the Active Directory distributed system, like many other distributed systems, is all but undetectable with the exception of the symptoms that our users experience, such as a password that works in one place and not another.
Right.
So, second recommendation, just to bring that down to a short point, make sure that you deploy the Active Directory DIT, logs, and sysvol on a data disk. That doesn't support write behind caching, subsequently all of your writes become durable. The third point, if you want to connect your Active Directory domain controllers back to your corporate on-premises network, that's going to require some kind of technology to join the machines in the cloud to the corporate network itself.
Right.
Now in the past and through a number of different avenues, I've tested a number of ways of achieving this. One of them was using a project called Sydney, or Windows Azure Connection Endpoint, or WACI, as I like to call it.
WACI.
I'm not sure my friend that's standing at the side of the stage there would agree with my little definition there. That was an IPv6 only agent that basically provided a relay in the cloud. Any computer and virtual machine in the cloud that was running the same subscription service instance of the agent were able to communicate with one another. It doesn't scale well enough, though, for the requirements of site-to-site Active Directory domains. I need 10 DCs up in the cloud, or 5 DCs in the cloud, and 10 SharePoint instances. I don't want to have to run the Sydney agent on all of those, and then run it on every machine on premises, every single one, all 10,000 of my clients. It just doesn't work properly,
right.
And certainly not on the DCs. So what the Azure folks did is they extended that notion into something that they previously called Project Brooklyn, which eventually became Windows Azure Virtual Network, which is a technology that allows you to take some ownership of the IP address space in the cloud, including things such as DNS settings, and make sure that they persist with a given VM. And also it has a site-to-site VPN capability that connects those virtual machines back into the on-premises network at layer 3, making them appear to be transparently connected to the corporate network. So again, to distill that down to a short point, the third point that's required to deploy a DC in the cloud is make sure, assuming that you require connectivity with your on-premises network or domain controllers, that you deploy Windows Azure Virtual Network, deploy the site-to-site VPN capability of it, and deploy an endpoint that is compatible with its requirements, which last I checked were IPsec IPv1 VPN endpoint deployed on the edge.
Okay, there's a couple of other questions that I want to bring up. I want to hit 2 points based on these three things, and just so folks at home know, tweet your questions, hashtag #CH9Live. All right, I want to go take a step back to the data disk piece. Are there differences when I'm thinking about sizing data disks, running Windows Azure running an Active Directory domain controller, Active Directory domain services in Windows Azure, versus when I run it on premises? Is there really a difference? Have the guidelines changed much recently?
Well, when you run it on premises, you tend to have an ability to choose ownership over where the machine runs on a given hypervisor. Although they're not typically the same team, you can normally communicate with them. You're in the same building, work for the same company. Obviously, you don't have that luxury with Windows Azure, but according to the sizing of the VM, you do get to dictate whether or not I share CPU cores, for example.
Right.
You do get to choose the amount of memory that's assigned to the virtual machine. And obviously, there are guarantees around compute capability, etc. Mm-hmm. In terms of disk, I don't know of a single Active Directory database that's remotely close, with the exception of perhaps Exchange Online and some of our online service providers, but even they're not close yet, to the capacity of a single Azure data disk, which is 1 terabyte. So with that in mind, I have no concerns about the sizing capabilities of running the DCs. Now, what the exact perf deltas look like between running a production DC in Azure and running a production DC in, say, Windows Server 2012 Hyper-V on premises, we don't yet have that data, but it's certainly something we're going to explore.
Okay. Going down to the next section, your third bullet point that you had, we talked about connectivity, site-to-site connectivity. From my on-premises directory services to what I'm running up into Windows Azure.
Yeah.
That now brings me to my next question of the things that Joey has done in his career that breaks Active Directory. It's sites. Okay. Proper configuration of your sites, your site links, everything else there. This is one of these things I look at this and I go, this could get really complicated.
It could.
I'm not quite sure where you are in terms of your documentation. I know you're gathering a lot of information. We've just gone into preview, so do you have some early recommendations
we
in terms
certainly
of
do, yeah,
doing
absolutely.
some of the site linking and some of those things?
So if we take that question and tease it apart into the how would I define the Active Directory site and topology to best optimize for a domain controller that runs in Azure that communicates with a domain controller that runs on premises, presumably for replication or even trust purposes, but this mostly applies to the replication scenario. The way that we're thinking about it, and this is in the documentation that we've already got published, it's about 95% complete right now, and it's lacking a couple of ADFS scenarios, but all of the ADDS scenarios are in there, they're online. Binging for that right now doesn't turn up too good a result simply because we haven't yet had sufficient time for it to be scavenged, but that link will become more readily discoverable shortly. So the documentation is out there. I won't give you the URL right now because nobody's going to remember it, and I'm not sure I can.
That's fine. I'll go ahead. These sessions are, of course, recorded, so you can go back and watch them, even though there's a lot of you that are here watching live. We're going to record this, so I'll put that link in. I'll get that link from you, and we'll drop it right into the recording so
Absolutely.
You can just check back a little bit later.
So again, then the short story becomes treat Windows Azure as you would any other site.
Okay.
So we have subnets that are configurable by virtue of the Windows Azure Virtual Network.
Yep.
So I have a subnet up there. I can see what that subnet is very, very clearly, and all of the IP addresses of the virtual machines that are attached to that virtual network fall within that subnet. That's exactly the same as it is on premises. So if I treat that in the same way as I would on premises, I now have to create a brand new Active Directory site using the Sites and Services UI or any tooling of your own choice, define a subnet, associate it with that site, and then carefully model the one last piece, the site link, figure out where the VPN endpoint is that the Windows Azure site-to-site VPN connects to, find its site in Active Directory, and then create a site link that contains that site and the Azure site. The last piece of the puzzle is taking the word cost into account, but with two definitions. There is a cost that's configurable on Active Directory site links that's used to dissuade our DC location component, aka DC locator, from using domain controllers if it can find one with a lower aggregate cost.
Yep.
So it literally measures the number of sites and the site links that it has to traverse to get to a DC based upon the position it's at on the corporate network, and the domain controllers can return the effective cost for you to get there. If the Azure cost appeared to be less, it's going to bias that. So what you're going to end up with is a lower Active Directory cost and a much higher Windows Azure cost, because all traffic, egress traffic, not ingress, let's be specific there, all egress traffic from Azure does have a fee associated with it. It's minuscule, but minuscule when you multiply it by tens of thousands of clients and tens of thousands of servers and hundreds of DCs that are replicating between these sites, suddenly doesn't look minuscule at the end of the year. So right. You do need to make sure that you optimize for that. So my recommendation is make the site link cost that connects the corporate on-premises sites and your satellite branch offices where all network transit is free, make the aggregate cost there always less than the single hop cost to get to the VMs that are running DCs in Windows Azure Virtual Machine. As long as that's the case, then we will only ever use that link and those DCs that sit on the end of it in the case of a failover scenario where nothing else was better, or because they're the only guys that offer the service we want.
And then, of course, your normal replication scenario.
Everything else then just behaves as normal.
Right. Yep. You mentioned that, and this, I'm sure you hear this question quite often, federation versus running full directory services, particularly when you start looking at cloud applications. And I think that might even tie in a question that we've got here online, security concerns, right? I remember early on when we started having public-facing applications that may require a domain controller and a DMZ. I think I have quite a few gray hairs from that initial configuration and fighting with that. So let's kind of couple questions here. So let's first talk about the implications, or when we choose one over the other, or if there is some. I know it's hard without looking at it in each individual scenarios, but some key kind of points there about domain services versus federation, right? Running it there, and then talk about some of the security implications that we talk.
So I think the prominent
running it out there.
Okay, fair enough. The prominent question to me is one of application compatibility.
Okay.
If my applications support, depending on your definition, Windows integrated auth or integrated Windows auth, depending on which way around you prefer that, they want to consume NT tokens. They don't want to see a SAML token, for example.
Right.
And if they need an NT token, then we need an NT-style trust, which essentially bubbles out as an NTLM trust or a cross-forest Kerberos trust. If, however, my application is claims-aware, it's SAML-based, for example, now I can suddenly start exploring the notion of using a federation trust and taking some peace of mind that I get to orchestrate precisely what claims flow between the two instances. I can transform the claims in transit, etc. I've got all of those luxuries. Some of those similar luxuries do apply with Windows Server 2012 by leveraging DAC claims or dynamic access control claims. So I can get some additional peace of mind, even though I'm using Kerberos, by using claims. But again, it's still down to whether or not the application can leverage our brand new, even albeit NT token style of claim. And that is just an app compat question that we can't yet answer.
And it's the same, it's literally the same as if I was running everything on premises without even getting Active Directory.
Yeah, the question of what I deploy in the cloud, I don't think is fundamentally influenced from a technological standpoint.
Right.
Assuming that you've got Brooklyn in place and assuming you stick to those other guidelines that I mentioned a second ago. It's not a technological question in terms of I'm running in Azure, should I do something different there? It's more about the app compat, what the services are you're trying to provide, and what the consumers of that service are, and the compatibility requirements that have to be met.
Okay. The next thing is security. You know, it started with you never, ever, 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 ever place a domain controller outside your firewall. Some things changed. We do some things with security, able to do that now. Now we're asking, now we're going to see IT departments going and asking some of their internal security guys, because they're looking to deploy and migrate applications running on premises up into Windows Azure to place domain controllers essentially in the cloud, on the internet.
I would
to
say
a certain extent,
there's
right?
a distinction between those two.
Right.
So you place it in the cloud.
Some security guys may not agree with you, but
yeah, I mean, I've certainly met those folks. But to my mind, so let's put it from my perspective, there's a distinction between running a DC in the cloud and placing a DC on the internet. Azure has a notion of a VIP and a DIP. A VIP being a virtual IP and a DIP being a dynamic IP. If I do not configure a VIP, then there's no public-facing port exposed to the internet. My DC is not on the internet. It's no more on the internet than it is when it's running inside my corporate network. It's simply down to the fact, did somebody set up a port forwarder with a port and an IP address on the edge that went directly to that DC so that people could reach it? If you don't define a VIP in Azure, you don't have that. If you don't do that on premises, you don't have that. So that distinction, I think, should be put at bay initially. Then the question comes down to, am I comfortable running a domain controller in Windows Azure? That comes down to a question of trust. Do you trust Microsoft? Do you trust the Windows Azure folks to configure and host and manage their data centers properly? And do they have the level of compliance that you require? Now, they're striving for additional levels of compliance as time goes by. But obviously, out the gate, they haven't got every single one. From my standpoint, and then speaking in my former capacity as an MVP and as a consultant, I would have been comfortable getting my customers to put domain controllers in the cloud, because I think the benefits outweigh any somewhat FUD-like concerns that I might have around the security. Obviously, Microsoft is going to go above and beyond to make sure that these machines are, one, well-maintained, properly managed, and secure. So I don't really have any concerns around that security aspect myself, but I know that others will. People have different perspectives on it.
Sure, absolutely. And you bring up a great point when you start talking compliance. I mean, that's one of the biggest reasons when we start looking at when does it make sense for us to start moving applications into the cloud. So that's awesome. Let's shift directions, take our heads out of the cloud, so to speak, and let's start looking at virtual machines running on premises or within maybe even we'll call it private cloud, right? Sure. Within the way we typically have done it. There have been some pretty major changes in Windows Server 2012, particularly around directory services and virtualization. Now, again, very similar to other things, we used to say don't do it, don't virtualize domain controllers, and then you can virtualize domain controllers as long as you do X, Y, and Z, right? Now we are changing the game a little bit with some of the added features in 2012 and talk about that a little bit.
Absolutely, so let's start with the past. So in the past, we did, I remember reading some 10 years ago statements in the very, very early days of hypervisors, do not deploy Active Directory domain controllers in hypervisors. I don't know what the sentiment was behind that original recommendation, but I think it was a matter of proof. Make sure the technology is sound. You don't want to just, put your distributed system that fundamentally runs your entire Windows ecosystem in a virtual machine that we don't know whether it works properly and any of the artifacts that it might bring to bear. I think over time we eventually changed that message to the point where somewhere around 2004, 2005, our guidelines consisted of best practices for things that you should and should not do when running Active Directory domain controllers in a virtual machine. Therefore, there's an implicit recommendation. That's fine if you do. Essentially, what it comes down to is a single guideline. Whatever you do, do not roll an Active Directory domain controller back to an earlier point in time without making it aware of the fact that you've done it. Another way of phrasing that is use backup and restore technologies that Active Directory is implicitly aware of. They are designed to inform the directory database you have been restored to an earlier point in time. From a technical standpoint, when Active Directory receives that notification, it resets its invocation ID, it discards its RID pool, it ensures that anything that needs to be unique, any immutable identifier that was associated with its previous existence that might interfere with the distributed system is reset. Therefore, other domain controllers treat it as essentially a very well populated, in terms of I've got a lot of data already, but right. Otherwise new domain controller. Subsequently, we don't introduce USN bubbles or create duplicate security principles. Moving on to Windows Server 2012, what we did here is we realized that virtualization is now the norm. It's not the exception anymore. It is the way that people want to deploy their virtual machines, and for good reason. Let's face it, the management is greatly simplified.
Sure.
Certainly the deployment aspects. So taking both the management and the deployment of these virtual machines into account, we had to figure out, well, how can we make Active Directory safer than it is today? I.e., if somebody inadvertently doesn't follow those guidelines, can we make it technologically defend itself? So we came up with this notion of something called VM Gen ID, or Virtual Machine Generation ID. And that's something that's plumbed in to the hypervisor. Then we had Active Directory as a virtual machine, and as an operating system, and as a role, be capable of consuming and using that Virtual Machine Gen ID. Essentially, the Virtual Machine Gen ID is a number that changes every single time a significant operation happens outside the scope of the guest operating system, but within the scope of the hypervisor. An example might be, I take a snapshot.
Yeah.
We don't change the Virtual Machine Generation ID at that point. We only change it when somebody restores the snapshot. Now, I want to be clear here. I am not recommending that you use Snapshot Restore on a hypervisor as an alternative to backup restore technologies.
Okay.
Because we have done our darndest to capture every single scenario where that might introduce what I term as distributed poison or USN bubbles. But there could be something that we haven't quite seen. There are scenarios that we realized very late in the game. There's one that we didn't capture, which I'll allude to in a second. So I'm not recommending that as a replacement. But essentially, the VM Gen ID gives us a vehicle by which we can detect significant hypervisor operations that would otherwise damage the Active Directory distributed system and automatically defend ourselves against them. The other feature was around deployment, because obviously hypervisors and virtual machinery trivializes deployment, because I've got a virtual machine disk, and I can copy it, and lo and behold, I've now got 2 machines. And I can copy both, and now I've got 4. So it occurred to me, why don't we do that for virtual DCs? So what we enabled was something called virtual domain controller cloning, whereby you can prepare, using a set of PowerShell scripts and an authorization action in a specific group in the Active Directory domain, you can prepare a single virtual domain controller for cloning, shut it down, copy its VHD, bring it back up again, or copy it as many times as you need DCs, and then turn them all back on, having deployed them to new virtual machines. They'll come up, they'll detect this clone config file, that's the result of one of those PowerShell scripts I mentioned earlier. They'll detect that their virtual machine gen ID has changed by virtue of the fact that they're running in a new virtual machine. That's obviously going to have a different gen ID than the one from which the VHD was copied. And as a result of those 2 things, they assert, I must be a clone. At which point, they go through provisioning logic and run through a piece of the install from media code path, the DC promo install from media code path.
Yeah.
So we're not reinventing the whole wheel here, we're just providing another entry point into it to trivialize the deployment of domain controllers by using hypervisor technologies. Today, the only hypervisor that supports VM Gen ID is Windows Server 2012 Hyper-V.
Okay.
Azure will support it at some point, and I'm directing those fingers again toward the audience. They will at some point support VM Gen ID, and we have also proactively informed both Citrix for their Zen product and VMware for their VMware ESX server product and their other virtualization platforms. And we have good indications, I can't say a commitment, but good indications they will indeed provide support for VM Gen ID.
And from a technical perspective, if I'm looking to deploy and leverage this, you mentioned the hypervisor level, which that has to be. Does Active Directory force functional domain functionality, or is it just a domain controller have to be a particular
Great question. So there's no functional level dependency. The two requirements for cloning or virtualization safeties, as we call them, the two requirements for those features to be fully in play are a VM Gen ID aware hypervisor, again today, only Windows Server 2012 Hyper-V, nothing earlier, and it must be Windows Server 2012 domain controllers. They're the only ones that have the code in there to be specifically cognizant of a VM Gen ID changing from one value to another. Any earlier release of the OS doesn't even know that Gen ID exists.
So we've got about a minute left, and I want to just ask you one more quick question around that stuff. When you talked about using the Gen ID initially and snapshotting, you said, look, I don't recommend it. We've got it there. It's a safety net, so to speak. When you talk about cloning, are you now, is it an okay kind of thing to really leverage that versus the standard ways that we do things, right? Which is demote, promote.
Absolutely.
Demote,
Cloning was designed to be a proactive and better, more optimal replacement for deploying DCs in virtual machinery. The virtualization safeties are exactly that. They're not meant to be something that you change your best practices, your administrative approaches for. They're there to protect you from making mistakes. As far as we can tell, we've nailed it. But there might be small nanosecond wide windows in there where a change doesn't get trapped quickly enough and a couple of USNs leak out. I don't believe there is, but there could be. So they're there to protect you from yourself.
Sure, I understand. We're also in that magical window of the release preview.
Indeed.
So we'll actually absolutely leverage that. I could sit here and talk all day, but it's time to get the folks at home who are watching live over to Taste of TechEd, because we've got 10 deadly sins of administrators around Windows security.
Well, that sounds more enthralling than me.
So Paulo's going to talk about the 10 deadly sins. Make sure you come back, because after that we're going to have more activity here on Channel 9. Tweet us at #CH9Live. We'll see you in about an hour and a half.